தெரிஞ்ச என்ன போறீங்க? Yes, sir, I'm available. This is my immense pleasure to introduce our special thing. A man carries 9 degrees. Such an inspiring person. Today we are going to meet. Of experience. He dedicated his past 19 years in academic. He finished 9 degrees in various premium institutions. BBA in marketing, Punjab College in Sivagasi, MBA in financial systems, PSG College of Technology, MPhil in management, BL in criminal government law college, MCA in artificial intelligence, Bharatdasan University Trichy, ICWA cost accountant, PhD in management in ANOVA University. ACA in company secretary, ML in business law under University of Madras. Having great divergence.
Okay, so cos beta is 2. Find what is beta. Beta is, so B or beta is, now when there is a 1 unit increase in x, increase x by 1 from 10 to 11. Then what happens? Y increases by 2 because my beta is 2. So when my beta is 2, which means when I increase x by 1, y will increase by 2. That is, suppose if beta is 0.5, then what is the meaning? When I increase x by 1 into 0.5, so it is a 0.5, so y will increase by 0.5. That is the meaning. Suppose if my beta is 3, what is the meaning? Y will increase by, now beta is 2, what is the meaning? You will get some marks, that is the A. So without the influence of x, you will get some y value, that is called A. Alright, so that you need to understand, right? Now, okay, so now the same thing I am explaining, but little mathematical also we will try to understand. Now first I put x is equal to 10, y is equal to 11. Now my equation, what is x is equal to 5, beta is equal to 2. Same example what we have taken. Okay, x is equal to 5, a is equal to 5, b is equal to 2. Okay, now when my x is 10, my y is 25. All right, that we have calculated. 5 plus 2 into 10, 25. That and all we have already studied. When x is equal to 11, same a, same b, a and b are constant, right? Only x and y will change, variable, that is the variable. So my y is equal to 27. I put 25, I should put 27. Dependent variable, because that we need to understand. All right, because income influence is saving. So saving is a dependent variable. Yes,
so excuse me, sir. Actually, there is somebody who has, presenting. Muruganandam Subban is presenting, so your screen is not visible.
Okay, whenever.
Madam, please.
Very much yeah, till now.
Madam, is visible, madam.
So there is another person by name Muruganandam who has, presented. That's why sir's screen got, it was
madam,
not presenting.
Madam, you pin it, madam. You pin it. It is on the SAR, you have to select the SAR presentation, and its pin is there. Just you pin it. It will not disappear. Okay. You
Yes,
choose the
ma'am, yeah.
SAR screen, and it is the pin. It is like a pin
No, no,
logo is there. Just you pin.
no. Okay. So now, what is a metric variable? Metric variable means for variable we can find out a mean, meaningful mean. Average we can find out. So for second we cannot find out for a categorical variable, right? So here for both variables we are using mean. So we should use only metric variable. So now this is the process which I do the analyze. So first I will go, then regression, then linear. So analyze, regression, linear. Then from this, I will take dependent variable total monthly saving on the dependent, and monthly income, total income is independent. Okay, I will select like this. Then, okay, then result will come. Then I will come back. So this data set, everything I have given, I have mailed to Shivkumar. Okay, he will send it to you. I didn't touch any of the options. So which means these are all the basic. Okay. So you are getting basic output because certain things are default in the statistics. Because in the statistics, so already estimates and model fit is, that is why you are getting these two statistics. Now if you don't click this, you will not get the coefficient table. Alright, that three table, no, model summary, ANOVA table, and the coefficient table. Coefficients are estimates. So if you deselect, not get coefficient table. If you deselect this model fit, if you deselect this model fit, that ANOVA table and model summary table will not come. Model summary table and ANOVA tables, two tables are model fit table, and the coefficient table is a estimate table, right? So that is why we are getting now. Okay, now I have a three table. Now I am going, that is the class today. I have a three table. Okay, I am going to explain each table one by one, right? So that is the purpose today. I have to complete it. Even if it goes beyond 12 o'clock, I have to complete these three. Okay, so now, okay, I have a three table. Now, so I have selected this one. I didn't touch anything. I put that. Then if I put that, I will get three table. Okay. Now first what we need to see. Okay. In the three table to see, you have to look at the significant value. First you need to look at the significant value. If the significant value is less than 0.05, then we have to reject the null hypothesis. Simply, if the significant value is less than 0.05, reject H naught. Okay, so this is what we need to do, right? Okay, so now let me tell you again. We have to look at the significant value. If the significant value is less than 0.05, then we have to now. Okay, now let me look at the significant value. Ignore, which means we are not committing error. So by rejecting the null hypothesis, we are not committing any error. So you can reject. So when my significant value is less than, so I can reject. Alright, rejecting. Why we are rejecting? Because it is not true. Because it is not true. So that is why we are rejecting, which means we are not committing any error. Our error is very, very less. Okay, so my error level is type 1 error is very less, which means I can reject false. It is false. That is why I am rejecting. Okay, so what is significant value? It is nothing but probability of committing type 1 error. Right. What is type 1 error? Rejecting H naught when it is true. Okay. So this is some more, there are some more meanings or other that we will come later. This is what you need to understand. Okay. But what we need to know is if it is less than 0.05, reject the null hypothesis. Otherwise, when it is less than 0.05, there is an influence. Simple matter is over. Okay. Now, we have understood this significant value. That one thing we have understood, right? So we need to understand other things also. Okay, we need to understand the other thing also. Now we will go to the next value, which is a t value. Okay. So now I am showing one table value. Extract from t table I am giving. Now, when my significant value is 0.1, at that point, my t value will be 1.64 in a table. Significant value 0.1, 10%. My t value is 1.64. My significant value is 0.05. Table I am telling 1.96. Significant value is 0.01. T value is 2.58. Okay. So which means, so complementary to significant level is confidence level. So when the error is 10%, confidence is 90%. When the error is 5%, confidence is 90%. When error is 1%, confidence is 95%, complementary. Now we will let us look at the significant value and the t value. 10%, 5%, 1%. So my significant value is reducing. My t value is increasing. So when the significant value decreases, t value is increasing. Otherwise, I should not tell like that. When t estimate increases, my p value will decrease. That is the meaning. My estimate, any estimate, whether the chi-square estimate or any estimate, F estimate or any estimate. When estimate increases, p value will decrease. Now here, when t estimate increases, p value will decrease. So now we are looking at 0.05, right? We want less than 0.05, then there is an influence. Okay, when my significant value is less than 0.05, I tell there is an influence. Now, I'm going to tell from t value basis. Oh, what I can tell? When my t value is more than 1.96, which means there is an influence. Now, you can look at the significant value. Otherwise, in a regression I'm telling, you can look at the t value. When the t value is more than 1.96, which means there is an influence. Simple. First point, when the significant value is less than 0.05, there is an influence. Second point, my t value is more than 1.96, which means there is an influence. Now I am going to put you the same table I am repeating. Now same table, whatever I have shown there, I am putting again. Now here we have already stated significant value is less than 0.05, so there is an influence. That is what we have concluded. That we have concluded earlier. Now we are going to look at this t value. Here my t value is 10.351 for total income. Right, that is my independent variable. Right, I want, what is my purpose? I want to find out my total income influence total saving or not. Total saving is a dependent variable. Total income is independent variable. So I want to find out whether total income influence the total saving or not. Here significant value is less than 0.05, which means total income influence the total saving. That is the conclusion we have derived. Now we are going to look at the t value. Here t value is 10.351, which is more than 1.96, which means there is an influence. Simple. Right? Okay, that is what we have stated. When the t value is more than 1.96, there is an influence. Now, what is t value? What is t value? Now, here we said that influence we determine based on beta. Right? We set beta. Right? We set beta. Right? Whenever we say no influence, beta is 0. That is the meaning. Okay. So here we say that beta, okay, there is an influence, which means beta is significant. That is the meaning. So now I am going to tell whether there is an influence or not based on beta, right? So beta is my estimate. So beta is my estimate. So estimate, that is a beta estimate, otherwise beta coefficient divided by standard error is the t value. So 0.11 divided by 0.016, which is equal to 10. So what is t? T is unstandardized coefficient divided by standard error. Otherwise, beta divided by standard error is the t value. Beta means unstandardized beta. Right. So only for unstandardized values you will get error. You will get error. If the values are standardized, then you will not get any error at all. Okay. So only for unstandardized you will get error. Only when you have a error you will get a t value. Because what is t value? T value is nothing but beta divided by standard error. Then only you will get a t value. Only when you have a t value, you will get a significant value. Okay, all are corollary, right? Very good. Okay, now, so now my beta is, okay, now I know what is t value. Now I know what is t value, right? Very good. I know what is significant value. Now I know what is t value, right? So now what is beta? The 0.161. So beta, how it is estimated? There is a formula. Okay, so covariance divided by variance of x, that is the beta. Okay, variance of x, that is the beta. Right, very good. Now you need not worry about it because it is given. But I will give a formula for everything later, but not necessary. Now we have a beta. Okay, now this is my beta 0.161. What is A? A is 3281. My A value is 3000 constant. Okay, this value is my A value. 3281 is my A value. This is my beta value, 0.161. Now what is my equation? Y is equal to A plus Bx. What is my equation? Y is equal to A plus Bx. Okay, A plus Bx. Okay, so now I'm going to write A plus Bx. So what is A? 3281. What is B? 0.161. So I can write an equation. What is my equation? Y equal to 3281 plus 0.161 into x. Okay, so now I know what is y. What is y? Savings. So y is savings, which means monthly savings equal to 3281 plus 0.161 into monthly income. So now I have substituted what is y and what is x. So now what is the first step? You need to look at the significant value. If it is less than 0.05, there is an influence. You can look at the t value. If it is more than 1.96, there is an influence. What is t? T is beta divided by standard error. So now we know a value. Now we know b value. So with this, you need to write an equation. You can write a general equation. Y is equal to 3281 plus 0.161 x. Otherwise, you can substitute the variable name and you can write. Very good. Now this is over. Now we have discussed about the t value, right? Okay. What is t? Estimate. What is my estimate? Beta is my estimate. Beta divided by standard error is the t value in regression, because in regression I am looking at a beta. Beta, know whether there is an influence or not beta. Sorry. Now, like the same for all other statistics also. See, for example, we will look at the we will look at let us assume that independent sample t test, where we will try to find out whether there is a mean difference in mean. That is the estimate. Now there t is that difference divided by standard error. So that t is nothing but what is the estimate divided by standard error. In regression, my estimate is beta divided by standard error. If it is t test, the estimate is the difference in mean divided by standard error. So t is estimate in general form divided by standard error. Okay, so that is the general form we can put it. Okay, now I am going for another table. So table 1 is over. I am going for another table, model summary table. In a model summary table, first I have a R value. What is R? R is correlation. You know correlation, right? If it is a simple regression, you will have only one y, one x. So it is a relationship between x and y, correlation. But if you have a multiple regression, you will have many independent variables. So, but you will be getting only one R. All right. So when you have many independent variables, how can you get one R? Not possible. So R is correlation between y, that is the actual y, and the predicted y, calculated y. Okay. So now what is R? Relationship between actual y value in the whatever available in the variable and the calculated y. How it is calculated? Y is equal to you give different values for x with this coefficient, you will get y. That is called y hat. We call it as y hat cap. Y hat. Okay, that is called y hat. So I have written y is equal to a plus bx. That is wrong. Y hat equal to a plus bx. That is the right. So what is y hat? Predicted value, otherwise calculated value. What is calculated value? Based on this equation, when you have calculated some value, that is the calculated value. The relationship between the actual y and the calculated y is the R value. Very good. Next is R square. Okay, here what is R square? Okay, now R square is nothing but square of R. 0.04 square is 0.16. Okay, that is the R square. So normally I used to demonstrate how it becomes a square of R, all these things, but that will be going away when I take regression for 3 days. Then that time I can tell. Now I will not tell. But one thing please understand, R square is square of R, right? What is R square? R square, we call it as degree of determination. R square is degree of determination. That is very, very important. What do you mean by degree of determination? What extent we determine Y? We are determining Y. We are determining Y. What extent it can be determined with the help of X? We cannot determine the actual Y, not possible, right? We will determine only certain extent. What extent we can determine? That is called R square. So here, R square is 0.16, which means I can determine only 16% of Y based on this X. That is the meaning. Only 16% with this one variable X. So which means the actual Y is coming from many other variable. Only 16% we can determine with the help of this one. So R square is very, very important. So whenever we determine, okay, so why we call it as determine? So this regression is a estimate. Why we call it as a estimate, that estimation, prediction? Why we call it as prediction? Because we are predicting Y with the X. We can use it for future also. Now, if you know how many hours that gentleman studied, then you can tell what is the mark he will get. So it is a prediction. We are predicting. What is it? Okay. Now, whenever we are predicting, what extent we can predict, that is the R square. Right. Please understand why regression is popular, because we are trying to predict the future. Now you know Y is equal to A plus BX. Now you give some value to X, then you can find out Y. So that is why it is a prediction technique. We can predict the future. But to what extent we can predict, that is the R square. Only 16% we can predict with that. Now, what is R square? R square is equal to regression sum of square divided by total sum of square. Regression, predicted sum of square, degree of prediction. Okay, so regressed sum of square or predicted sum of square divided by total sum of square. What is the predicted sum of square? Okay, Y hat minus Y bar square. That is the regression sum of square. Regression sum of square is equal to Y hat minus Y bar square. That is the regressed sum of square. What is the total sum of square? Y minus Y bar square. Y minus Y bar square. What is residual sum of square? Y minus Y hat. That is the residual square. Okay. So now my R square is regress. What is predicted sum of square divided by total sum of squares. Okay. The total sum of square equal to predicted plus residual. That is the total. What is predicted, what is not predicted. Okay. So now my R square is 0.163. See now, sir, what is this, sir? Whether we can calculate all these things? Yes, you can calculate. So all calculated value, saving calculation, all calculated. But if you look at the another table, that is the ANOVA table. We have another table. In that table, here we have regressed sum of squares. You can see 29, 0, 9, 1, something like that. We have residual sum of squares. We have total sum of squares. Okay. So how it comes, that also we can calculate. Everything we can calculate. It is calculated and given. That Excel sheet is given to you. Now 29, that is my regress sum of square. Total is 17, 18, something. Right. That is the 10 digit. This is the 11 digit. Now R square is equal to 29 divided by 17, which is equal to 0.163. That is the regression sum of square divided by total sum of square. So what is the regressed means? Predicted divided by total. That is called the extent of prediction. So R square is extent of prediction, predicted divided by total. Okay, that is called the extent of prediction. So that values also we have in the ANOVA table. That is the another table we have now. In that table you can see regressed sum of square divided by total sum of square. All right. So now, okay, now this explained what is R square. R square is very, very important. You need to look at the degree of determination. Very good. Okay. So now we have another thing called R square, adjusted R square. That is the third one, adjusted R square. Now, what is the adjusted R square? Now you please see the R square, then you will understand the adjusted R square. Now this is my R square. What is the R square? 1 minus sum of square residual, right? Sum of square residual divided by sum of square total, 1 minus. If you put straight away, sum of square regress divided by sum of square total. Otherwise, divided by sum of square residual. That is my R square. Now my adjusted R square is same format I am writing. 1 minus sum of square residual divided by degrees of freedom. Degrees of freedom, D of E. What is D of E? It is degrees of freedom, n minus 1. Okay. So what is here degrees of freedom? Here it is n minus 1 only. So which means same R square adjusted for degrees of freedom. Okay, so now other way also you can find out, right? Adjusted R square is equal to 1 minus R square into n minus 1 divided by n minus 1, right? Here divided by n minus 1 divided by n minus k minus 1. N minus k minus 1. Okay, so now what is the relevance of this one? I will come to relevance of that. Okay, so what is adjusted R square, right? I will come. Now we will try to understand this ANOVA table, then I will come back. Now I said this sum of squares, this is the residual sum of square, and then this one, which means regressed is predicted sum of squares. Residual is not predicted. This is predicted. This is not predicted. This is a total. Residual is what not predicted. Now here my total in the data set I am going to put a total 552. I have 552 data. So my degrees of freedom, total degrees of freedom is n minus 1. So 552 minus 1, it is 551. When I have used only one independent variable, my regressed degrees of freedom is 1. So my residual degrees of freedom is 550. Okay, within difference 550. So total 551. What is mean sum of square? Mean sum of square is this regressed sum of square divided by regressed degrees of freedom. Here residual is sum of square, residual sum of square divided by this degrees of freedom. This is this one. Otherwise, regressed sum of mean sum of square is regressed sum of square for 1 degrees of freedom. This is residual sum of square for 1 degrees of freedom because divided by 550. Now f value is this mean sum of square divided by this one. Always f is mean sum of squares for regressed divided by mean sum of square for residual. Okay, this divided by this, which is equal to 107. What is the meaning of 107? Okay, the regressed mean square is 29 something divided by residual mean square. When f is equal to 2, what is the meaning? My regressed sum of square is 2 times of residual sum of square, the residual mean square. Only I will get f is equal to 2. All right. When f is equal to 2, which means this is 2 times of this one. Now my f is 107, which means my regressed mean square is 107 times more than residual mean square. So what is regressed mean square? That is the predicted mean square average. Predicted mean square. My predicted mean square is 107 times more than what is not predicted mean square, which means my prediction is 107 times better than what is not predicted, which means I am sufficiently predicting. That is the meaning. Okay, so now my significant value is 0.00, which is less than 0.05, which means there is an influence or sufficiently we are predicting. Sufficiently we are predicting. Now, what is f value? F value is t square. F value is t square. So normally we said significant value is 0.05, less than 0.05, which is, so 1.96 square is 3.84. So my f value is more than 3.84. My f value is more than 3.84, which means my significant value will be less than 0.05. Okay. Now, finally, what is the use of this ANOVA table? If my ANOVA is significant, which means I am significantly predicting. I am significantly predicting. Now, why this is a question? Because here my R square is 0.16, which means I am predicting only 16%. Which means I am predicting only 16%. Now there is a question. What is the question? Whether I am sufficiently predicting or not, there is a question. People might question you. When you send a thesis, the people might question you. Your R square is less. Which means you are not sufficiently predicting. Which means the variable which you have taken is not sufficient. You need to take more variables. That is the meaning. But when my f is significant, which means I am significantly predicting. I am significantly predicting. Okay, so that is why it is a model fit. My model is fit. So when you click a model fit, it is giving this result because this is a estimate for model fit. Now, when your ANOVA is significant, significant means less than 0.05, which means your model is fit, which means you are sufficiently predicting. Now, let me go back to adjusted R square. Now, what will happen? See, regress 1, which means I am taking only one variable. My residual is 551. Okay, so normally my residual is, okay, so the this total is n minus 1. That is the total. All right. If you have taken one independent variable, my residual become n minus 1 minus number of independent variable. So my independent variable increases. So my degrees of freedom for residual, my residual degrees of freedom will come down. My residual freedom will come down. So what will happen? My R square will increase. My R square will increase. Okay. So what will happen? Influencing. So for example, if you take one more variable, what will happen? My residual degrees of freedom will become 549. So automatically this value will come down. Okay, the residual square will come down. So what is my R square? R square will improve. So add more and more variable. When you add more and more variable, R square will improve. R square will improve without influencing. Also, see, when you have only one variable, you will be having some R square. If you add one more variable, definitely your R square will increase. But we want to know the increase in R square is really there or not. That is why we are going for adjusted R square. In the adjusted R square, we are removing the effect of degrees of freedom. Degrees of freedom at the adjusted. So in the R square, there is a bias of more number of variables because of degrees of freedom. Okay, in the regular R square, you have a degrees of freedom bias. Okay, because of increase in degrees of freedom, okay, decrease in degrees of freedom, your R square will improve. That bias is there. But we want to have whether the variable influence or not, degree of determination. Okay, by adding one more variable, our determination really increase or not? My real determination increase or not? My degree of determination increase or not? That we cannot judge from R square. That is why we go for adjusted R square. So adjusted R square is degree of determination without bias. Adjusting degrees of freedom, adjusting the degrees of bias. Okay, so now what will happen? What will happen? Normally R square will be from 0 to 1, but adjusted R square minus also will come. Okay, because the degrees of freedom we are increasing. Okay, so that will happen. Okay, so now you have understood the ANOVA also. Now, whatever we said, okay, what is the degrees of freedom? Okay, total is n minus 1, residual is n minus 1 minus k. Okay, number of predicted variables k. That is the degrees of freedom for that. Okay, so regressive sum of square divided by degrees of freedom. So residual is residual sum of square by divided by f is equal to regression mean square divided by residual mean square. That and all I have explained. Okay. Okay. Now I think I have explained but what I have not explained is in this table. Okay, so standard error, there is a formula. Okay, so only thing is this I have not explained. What is this standardized beta? Okay. Now, okay, so I am going for that. Before going for that, let me make it very, very clear. Number one, we have to look at the significant value. If the significant value is less than 0.05, that independent variable influence the dependent variable. That is the first one. Or otherwise, we can look at the t value. When the t value is more than 1.96, which means that variable influence that dependent variable. Okay. Okay. My beta divided by standard error is the degrees of freedom. Okay. Then fifth point, R square, that is the degree of determination. What extent we determine? Adjusted R square, adjusting bias of degrees of freedom. What is my degree of determination? Then ANOVA table, whether I am sufficiently predicting or not. When my F is significant, which means I am sufficiently predicting. These are all the information you need to know from the regression basic. Okay. Okay. Now I am going for standardized. Standardized. Okay. Now, to explain that, okay, though it is one column, small one variable, but it requires a lot of explanation. It requires lot of explanation because this is the basic you need to understand. It is used for other place also. That is why I am going to give emphasis here. Now, I am going to analyze. I am going for descriptive statistics and descriptives. And I am going to put both variables this side. I am going to select save standardized value as variable. Let me read again. Save standardized value as a variable, which means I will get a two new variable, which is the standardized values of these two variables. So I am going to select the standardized value of these two variables, and I am going to create a new variable. I am going to save it. That is what I am going to do. Right, very good. So now let me go there. Let me do that. So now I have two variables. Now I am going there. Analyze, descriptive. I am getting two variables. This box. I can use shift key. I can use control key, alt key. I can use an arrow to move from one place to another place, and here save standardized value as variables. Okay, then I am telling okay. Then I am going to go in there. I am having a two new variables. Earlier I got only these two. Now I am having a two new variables. Right? So that is what I have placed in the PPT. Okay, that is what I have placed in the PPT. So now earlier I had two variables. Now I got two more new variables. Okay. What is this standardized values? Standardized values are nothing but x minus x bar divided by standard deviation. Mu is x bar, right? Y minus y bar divided by standard deviation y. So x minus x bar divided by standard deviation x, for y minus y bar divided by standard deviation y. By using that, it is giving the new variable. Okay. So now, if you look at this one, you please look at the formula, right? Okay. Then x minus x bar, that difference. X minus x bar, that difference. Bar, right? Divided by standard deviation, which means 2 times. When my value is 2, when my standardized value is 2, what is the meaning? The difference is 2 standard deviation. That is the meaning. The difference from the mean is 2 standard deviation. That is the meaning. Because x minus x bar divided by standard deviation. So the difference x minus x bar, that difference divided by standard deviation. Which when it is equal to 2, which means the difference is 2. Right. So 2 times. My difference is 2 times of standard deviation. Right. Okay. Very good. Now this is a standardized values, right? Now please look at the standardized values. Please look at the standardized values. You can understand certain things. Okay. Number one, all values will range from 1 to, but it will not be more than 3, plus 3 and minus 3. Okay, if there is anything more than plus 3 or minus 3, that is called an outlier symbol. So if some people, they would be trying to detect the outlier. How to detect the outlier? Look at put the standardized values. If any of the value is more than 3 times of standard deviation, right? In a normal curve, your all range will be 3 times of standard deviation, this side. 95% will be between minus 3 to plus 3. So, because it is a standard deviation value, changed value, the difference value from the mean, right? So, that cannot be more than 3 times. So, if any of the value is more than 3 times, that is called outlier, we have to reject it. Okay, so that is called outlier detection. That is why I am teaching this one. The standardized will be used for many place, right? Very good. So how to get standardized value? Very simple. Analyze, descriptive statistic, descriptive, then select the variable for which you have to find out, save, you will get it. Okay, I got it. Okay, I got it. Very good. So now what I am going to do is, I am going to that this one. Now I am going to perform a regression, right? Not with the old variable, with the new variable. Analyze regression, linear, not in the old variable. I am going to put a new variable. That is the standardized variable. So total monthly Z total saving. Standardized score Z score, otherwise called Z score, otherwise called standardized score. Alright. Some people find out Z score, which means you need to go for a standardized values. Okay, let me show. Okay, simple. Now let me look at my beta value now. What is my beta value? 0.404. My beta value is 0.404. Here also 0.404. And here there is no change. Now, what is this? What is my beta value now? 0.0404. Now, let me show the, let me go to the PPT and let me show what is the values. Okay, so now 0.404. Now, this is my original estimate, original table, right? When we have used y and x. So, significant value 0.161, all this. Now, look at my standardized coefficient. It is 0.404. What is the meaning? Okay, so standardized coefficient 0.404 means when you run a regression with the standardized value, then what is the beta? That is the standardized beta. What is the standardized beta? When you are running a regression with the standardized data, you will get something that is called the standardized beta. That is called the standardized beta. Now this is what? Original. This is the new variable. This is the original one. Okay. So now what is beta? Beta is when there is a 1 unit increase in x. What is the increase in y? That I have explained. When there is a 1 unit increase in x, what is the increase in y? That is beta. Now what is standardized beta? What is standardized beta? Otherwise, I can tell when the standardized value increases by 1 in x, the standardized value increases in y. What is this standardized value? Alright, that is what now otherwise, now my beta is 0.404, right, standardized beta. Okay, now what is the meaning of standardized beta? I am going to tell. When there is a 1 unit standard deviation increase on total income, right, result in 0.04 standard deviation increase in total savings, because it is a plus, right? When there is minus beta, what is the meaning? When this increases by 1, that will decrease by that. Alright, for example here, right, by this regular beta. My regular beta is minus. My regular beta is minus. What is the meaning? When there is a minus, let us assume that it is 0.161. When there is a 1 unit increase in income, it decrease by 0.161. That is the meaning. That is the beta, right? Minus beta. Okay. We need not worry about minus beta, right? Minus beta means when x increases, y will decrease. Okay. Well, now our question is whether it is significantly influencing or not. Okay. So you need not worry about whether it is minus or plus. We need to look at the significant value. Okay. Minus means whether this is better over. Because we are multiplying with the minus beta. X into minus value. This will become minus. Okay, so now beta minus beta. Now standardized beta. Now here my standardized beta is plus 0.404. Now how I am writing? When there is a one standard deviation increase in total income will result in 0.404 standard deviation increase in total savings. That is what you need to write. Okay. Now, I'm going to run mean value. I'm going to run because you need to the standardized. You need to have some more understanding, right? So let me have descriptive statistics. Frequency. I'm going to put this new variable. Okay. I do not want a frequency table, right? I want to have mean, standard deviation, and the variance. Okay. So where I'm going, let me show again. Analyze, descriptive statistics, frequency, statistics, mean, standard deviation, and the variance. I'm running that. So now I will get a result. Now this is my result. Okay. Let me go there and take this. So now for a new variable 552, my mean is 0. Mean is 0. Standard deviation is 1. Standard deviation is 1. The average is 1. Okay, so now I'm going. See now for standardized value, if you find out the mean, now what is standard deviation? Standard deviation is deviation from the mean, right? Okay. Now what is standardized value? What is standardized value? X minus x bar, deviation x minus x bar, the deviation from the mean, right? Okay, divided by standard deviation. Then what will happen? Okay, so I said the values will range from 0 minus 3 to plus 3. So now you mean what is mean? Middle value. So 50% this side, 50% that side. So the deviation is when you take the summation of x minus x bar. Okay, so x minus x bar summation, you will get a 0 value. The average is 0. Okay, because so some value will be positive, some value will be negative. Mean is middle. Some of the value this side, some of the value that side. Okay, so always for a standardized values, mean will be 0, standard deviation will be 1, and variance will be 1. Variance will be 1. Okay. So one more thing also I will tell. Okay, for your future understanding, future purpose. Now I have a value, right? I have a value, right? I have a value. Now I am running a correlation between these two variables, x and y. I will get some correlation. Then if I run a correlation between both standardized, I will get same. I will get same. I will get same. Okay, so now let me run. Okay, so now analyze correlation. The correlation. So let me put first two. So it will be 0.404. We said no. 0.404, right? 404. Correlation is 0.404. We said to know our R value is 0.404. Okay. So now let me run correlation between two standardized values. Same 0.404. So when you take a standardized of the variable, the features of the variable will not lose. That is why correlation remains the same. Now by this time, you should have thought about what? When a standardized value, my correlation is 0.404, my beta is also 0.404. Always for a standardized value, correlation is the beta. Correlation is the beta. Okay, these are all something I am telling again more. You need not worry about it. Okay, leave it. What is required now is very simple. What is required now? What is required is what is the standardized beta? When my standardized beta is 0.404, which means when there is a one standard deviation increase on X, 0.404 standard deviation increase in Y. Now, what is the use of this one, sir? What is the use of this standardized beta? That question you should have in mind. Please reserve that now. Okay. Now, so you should think, wait, what is the use here? Right. What is the use of unstandardized beta? Evaluation only with unstandardized beta. Please remember. You have to write an equation only with unstandardized beta and the A value. Okay. Now, what is the use of this standardized beta? Okay, I will come. Okay, now I already have discussed about the residual. I already have discussed about the predicted and residual. What is predicted? Now we have seen the coefficient, right? 3281 A value, P value is 0.161, that we know, beta value. So by using that equation, you give different values for X. You give different X value. We have X value, right? X. You give those values one by one. You will get Y value. That is called Y hat. Predicted. I have told you Y is equal to A plus BX. That is not right. Y hat. It is Y hat. Y hat equal to A plus BX. Now by this equation, you will get one value that is called the predicted value. That is called the predicted value. Now, this is the predicted. We have some actual Y, that actual Y value, Y column. How to get that Y column? This predicted plus some error, that adds some error. Error may be plus or minus, that's it. Plus some error, you will get the Y value. So, Y is equal to Y hat plus residual. Residual we express by word E, residual. Error in prediction. Otherwise, what is not predicted? Error. So, Y equal to Y hat plus residual. So, Y equal to, what is Y hat? A plus BX plus E. Okay. So, now what is residual? Y minus Y hat. Okay. Y is Y plus residual. What is residual? Y minus Y hat. Okay. From actual Y minus predicted Y is the residual. Right. So now this also you need to know if you want to see work on the EViews, those things. We will be using this residual because okay now we are predicting only 16%, which means residual is more. Now people are inventing, people are trying to find out new regression models like ARIMA, Scotch, all these things. Mainly to reduce this residual error, this error portion. That is the econometrics is coming. So this error residual, which is not predicted, is high. We want to minimize that. So for which they are going for extended versions of regression. So new regression they are trying to bring it. Okay. So this is the some knowledge. Okay. Now here itself we can bring, if you want to see the predicted value, residual value, that also we can see here. Where to go? So if you go, I will go there, then I will show this slide. Okay, now analyze regression linear. Okay, so let me put original value. So total savings, here total income. Okay, now save in the save. Okay, what you want to say? Okay, I want to have unstandardized predicted value and unstandardized residual value. Standardized also I can get Cook's distance, Maranabi's distance, many things. See, these are all you can explore new things. Okay, but I am teaching top two only. Minimum teaching I am doing. Okay, continue. Okay. Now let me go and show the data. Now you get two new variables. Alright. So now this is the predicted. First is predicted by using equation. Right. So I have told you I have given some table, that is the one Excel, saving calculation Excel. How we made a calculator from this value, we have shown that also. Okay. Now this is the predicted. What is predicted? Predicted by using equation. Right. What is residual? This residual is, now this is the what is the savings, right? 13,500 is the saving y value. What is the predicted? 3,000. Then what is the residual? 3,000. 3,000, right? So 10,300 is the predicted. 13,000 actual. 13,500 minus 10,300, 3,100 something. All right, that is the residual, right? What is residual? Y minus y hat, actual minus predicted. Okay, now what is y? Y is equal to y hat plus residual. Also you have right, very good. Okay, this okay, so this is what we have done. Save unstandardized, predicted unstandardized residual. This is the result. Okay, now I completed regression. I completed regression, right? Shivakumar sir. Hello, Shivakumar sir.
Yes, sir. Yes, sir. Yes,
Ah,
sir.
very good, very good.
Yes,
So
sir.
now I completed regression. Now, not regression, simple regression, multiple regression I have. Now I have one question, Mr. Sir. Okay, so I will ask this question. If anybody is raising the hand, please unmute their microphone and ask them to give answer. Right, sir? Right.
Yes, sir.
Now,
Yes, sir.
okay. Now I have a very small table. This is the y value. This is the y value. This is my x value. Okay. Don't look at the third column. Look at my y value column and the x value column. Now, Now you have to tell me what is A value, what is B value. Over to participants. Anybody can give answer now.
Please unmute yourself. Unmute yourself. You have to answer it.
Hello, sir.
Sir,
Hello,
yes,
sir.
sir. It is audible. You can continue.
Good afternoon, sir.
Tell answer, sir. Yes,
A is
sir.
2, sir.
B,
Sir, A is 2, sir.
B.
B is 1, sir.
Wrong answer. Somebody else? Wrong answer. Okay, next person. You please unmute your microphone, sir. Next person.
Hello, sir.
Hello, sir.
Sir, y is equal to 2x plus 1.
Yes, sir.
Y is equal to 2x plus 1.
No, I am asking what is A, what is B, sir.
A is
Hello, sir. Hello.
A is 1, B is 2.
All wrong answer, sir.
Hello, sir. Sir, A 1, sir. B 2, sir.
Wrong answer. You look at Y and X, not the third column. First column and second column.
Sir, A is 1 and B also 1, sir.
Wrong answer. Somebody is shouting from the back. Somebody is shouting.
A is 0 and B is 2.
Yes. A is equal to 0. B is equal to 2. Now you put it to the equation. Right. So now A 0, Y is equal to 0, B is equal to 2. Right. 0 plus 2x. X is 1. 2 into 1, 2. 0, 2. Next is 0 plus 2 into 2, 4. Okay, very good. Very good. Now you have understood what is A, what is B. Now one more. Now leave the first column, take the third column as Y. Now my Y is 3, 5, X is same 1, 2, 3, 4. Yeah. Over to participant. What is A, what is B? Quickly, I have something more to say. Yes, quickly. Now leave the first column. Third column is my Y. Second column is my X.
Sir, A is equal to 1 and B is equal to 2.
Very good, very good. What is your name, gentleman?
Sir, Parthiban.
Parthiban.
From Government Arts and Science College, Satyamangalam.
Very good, gentleman. Very good. Good
Okay,
answer.
sir.
Now, okay. Now, I have another question. What is R square? You take first situation or second situation. What is R square? R square is degree of determination. Otherwise, first you tell me what is residual value.
Sir, R square is 1, sir. R square is 1.
Residual value?
Residual value, I just have to check, sir.
0.
Very good. Somebody is telling. Very good. Now, predicted Y hat. Predicted with the equation where A is equal to 0, P is equal to 2 for first situation. Predicted value also 246. Actual value also 246. Y minus Y hat is 0. Which means residual value is 0. Which means I am predicting 100%. Which means my R square is 1. Very good. Somebody has given 1. Who is that gentleman? 1. Who said 1?
Myself, Arun from Mumbai.
Very good, sir. Very good. That is a very great answer. R square is 1, sir. R square is 1. Residual is 0. Alright. Very good, sir. So, which means you have understood very thoroughly about regression, sir. Very good. So, now I have many more to say. So, I think I will take another half an hour. Right. Very good. Now I will tell one more. Right. I'm going to take one more data set. Okay, so now I'm going to take one more data set, that is a car sales data set. Only question now, right? See now, this data set contains sales and fuel efficiency, right? Otherwise, car sales, right? Sales of a cars, what is in volume, then mileage, their mileage, right? Sales and mileage. The idea is mileage. If mileage is more, the sales also will be more. People will buy with cars which are giving more mileage. That is the logic. Okay, which means fuel efficiency influence the car sales. Okay, so my car sales is the dependent variable. Independent variable is mileage. So I feel mileage influence the car sales. Now I am going to use it. So analyze regression a linear sales is a dependent variable, fuel efficiency is an independent variable. Okay, now I am going to say okay. Now this is my coefficient table. Now this is my coefficient table. I am going to put it in the PPT. Okay, now sir, who is sir? Okay, now okay, now Mr. Sivakumar, over to participants. So now I have the result. Now I have the result. Now this is my coefficient table result, where my mileage is the independent variable, sales is the dependent variable, sales of a car, mileage of a car, right? Now what do you infer from this table, that result? Now over to participant. One by
Sir,
one.
mileage does not predict the sales of car.
Very good. How do you say, sir?
Because considering t value and significance value, most important is significance value is greater than 0.05.
Very good, sir. Very great, sir. Very great, sir. Very
Not able
great.
to
Yeah.
predict.
Yes, sir. Very good, sir. Very great answer, sir. Now, my significant value is 0.837, which is greater than 0.05, which means mileage is not influencing car sales. The car sale is not depending upon mileage. People buy car not because of mileage, because of something else. The mileage of the car is not influencing. That is the meaning. So now my t value is less than 1.96. Don't worry about minus or plus. Okay, minus 1.96 or plus. Don't worry about minus. Okay, so minus is there because beta minus standard error. Minus beta divided by standard error is the t value. That is why minus. Don't worry about minus t. Okay, my t is less than 1.96, 0.206, which is less than 1.96, which means my car sale does not influence. Okay, now normally we will say when the beta is less than 0.05, we will reject the null hypothesis. When the beta is more than 0.05, we will say accept the null hypothesis. Less than 0.05, reject. More than 0.05, we will accept. But normally, we will not say we will accept the null hypothesis. What we will say is, there is no evidence to reject the null hypothesis. We will say, there is no evidence to reject. Right? Why? Because I will give a story, but I do not have time at all. That is why I am not going to give this story now. That is the system. How? Okay. Now, when significant value is greater than 0.05, we should accept the null hypothesis. What is the null hypothesis? There is no influence. What do you mean by no influence? My beta is 0. My beta is 0. Now, here what is my beta? 0.267. It is not 0. It is something. But something is not good. Not great. Okay, that is why the evidence which is available is not right to reject. Okay, so the evidence available is not great because in the court they will say the evidence produced is not that great. They are also evidence produced. So they have not proved with the evidence beyond a reasonable doubt. The police should have proved the case beyond reasonable doubt. Then only they will punish them. But police has not produced enough evidence. So we will say that person is innocent. He has not committed crime. So people will write like this because of this one. Okay. So now that is over. Right. So now I am going to show another data set. I am not going to run. I am going to just show why I am telling is. Now I have another data set. So this is all 5-point scale. All 5-point scale, 7-point scale. All 5-point scale is considered as metric variable. So you can perform. So now what I can do is, I can perform whether satisfaction leads to commitment or not. I can perform satisfaction independent variable, commitment variable. So I am taking one another variable with the 5-point scale. That also you can take. That is what I am trying to tell here. You can take. Okay. So I am not going to run more time. So next is what is next is okay. So the employee branding, dependent variable also 5-point scale and independent variable also 5-point scale, which means you can use. Now I am going to talk about another regression, which is a spurious regression. Now, what is the interesting data set? Okay, interesting. Now, what is the variable? Okay, I am going to take one variable, carbon emission in USA. What is the carbon emission in USA, America? Then another variable is life expectancy in China. Carbon emission in America, life expectancy in China. Okay, analyze now. See, now you should know that you should not perform regression because these are all two different variables. How come that variable influence life expectancy in China? You should not use that, you know. Alright, that you know. But let me perform, let me see what is happening. That is what I am going to tell now. So analyze, regression, linear, life expectancy in log of life expectancy in China, log of carbon emission in America. Now I am going to use it. Now you see here, hey, significant value is 0.00. Okay, significant value is 0.00. Which means life expectancy, carbon emission influencing the life expectancy. R square is 65%. Okay. Now I have a doubt. Now because how come it is possible? Right. So now what I am going to do is I am going to check, analyze linear in the statistics. All these things, at least one I should. In the statistics, I have one thing called Darwin-Watson for residual. Okay, whether there is correlation among the residual, that is the meaning. Darwin-Watson for residuals. Okay, okay. The collinearity, all these things I am not teaching now. Okay, so Darwin-Watson. Now let me perform. Okay. Now this output I placed. This output I placed in the PPT. Now let me show the PPT. Okay. Now you know that a significant value is 0.00. Right. Significant influence. T value is more than 1.96. Beta value is 0.636. My R square is 0.654. Now my Darwin-Watson is 0.081. My Darwin-Watson value is 0.081. Now in this case, my R square value is more than Darwin-Watson. R square value is more than Darwin-Watson, which means this is called a spurious regression. You cannot depend upon this regression. That is the meaning. The result is spurious, not reliable. Right. So the R square value is maximum itself 1. My Darwin-Watson is 2. Right. Darwin-Watson 2, R square is 1. So always my R square should be less than the Darwin-Watson. Here my R square is more than the Darwin-Watson, which means the is on that. You should not give this result. Okay. You should not use this. Right. Okay. Now we'll go for a multiple regression. What is multiple regression? Multiple independent variable. Instead of x, we are going to have x1, x2, x3, x4. Okay. Now we had a beta. What is beta? Extent of influence of x on y. That is the meaning. Extent of influence of x on y. That is the beta. Now I have a 3 independent variable, which means each variable is independent variable. I have only one dependent. So I am the only person in my family. My children, my son will influence, daughter will influence, my wife will influence. The influence of each person will vary. Influence of each person will. So x1 will have one beta, x2 will have one beta, x3 will have one beta. Okay, so we will have B1 for x1, B3 for x3, B1 for x1, B2 for x2, B3 for, so many independent variable. Each independent variable influence y. That influence we call it as beta. To distinguish beta, different value. So B1, B2, B3. So my equation is y equal to a plus beta 1 x1, beta 2 x2, beta 3 x3. That is the multiple regression. Now, what is the data set we are going to use? I am going to take up gold data set, in which my dependent variable is gold price, which is a metric variable. My independent variables are GDP, savings, inflation, interest rate, per capita, money supply, all metric variable. So which means in a multiple regression, one dependent, many independent, all metric, all right. That is the requirement. Okay, so that is the data set. Now, okay, so I will select that variable. I will put a many variable here. I will get the result. Right. So now let me go there and I will come back. Okay, now I am taking the old data set. I got only 12 data. So no problem. We can perform. That is the special of regression. Right. Okay. Analyze. Regression. Linear. Dependent is my gold price. Okay. Independent is all this one. So what is my objective? Whether this variable influences the gold price. Now the gold price is increasing. Why? Question, big question. Why it is increasing? Which is influencing? Okay, that is a question. So now this is a very old data that earlier 2010 there was a rise like this. So that time we want to find out which economic variable, right? We can take market variables, right? The investment in shares might have come down. That is why investments in gold might have increased. That is why gold price might increase. Okay. Now the fuel price might have come down. So gold price might increase. So like that, some market factors. Okay. So now all the people feel no asset is a good asset. So only this asset is a good asset. Like that, many perception, many things. So now that is why we are trying to find out what are the variables influencing the gold price. So gold price dependent, all other variable independent variable. Now I am going to say okay. Now I am telling okay. Now I have a set. Now I have a set. As usual, three table. Now I am going to take up that table to the PPT. Now I have a result. Okay. Now go to participants. Now that Arun sir, please you need not give answer, somebody else. People, those who have given earlier answer. Yes.
Yes, sir. Yes.
Now please tell the result.
GDP is
somebody.
influencing. GDP is
Very
influencing, and GDS also is some savings or something.
Yes.
Yeah, that also
savings,
influencing.
yeah.
And GDP-C also influencing.
That is the per capita income. Per capita, GDP per capita. Yeah.
These three are the influenced gold prices. The others are not influenced.
Very good, sir. That's a matter over, sir. Matter over. Right. Now, I want to write an equation. Very good. Now, I need to have A value. What is the A value? Somebody please tell what is the A value?
It's a constant, 9,912.
9,912. That is the A value. What is B1 value? B1.
11.
Yes. X1 GDP. Alright, very good. Clear? Okay. Now GDP is X1, beta 1 is 11. X2 is GDP savings, beta 2 is minus 387. X3 is inflation, beta is minus 2. So which means each independent variable is having beta. So these are all X1, X2. Okay, these are all X1, X2, X3, X4, X5, X6. This is beta 1, beta 2, beta 3, beta 4, beta 5, beta 6. So this is the A value. So now I am going to write an equation. Now three variables having significant value less than 0.05, which means only three variables are influencing. That is the question number 1. Now my equation is y is equal to a plus beta 1 into x1, beta 2 x2, beta 3 x3. So y is equal to 9,912 plus 11 into GDP minus, that is the beta 2, minus 387 into savings minus 112 into inflation. So this is the equation I have written. Right. I have written the equation. Very good. So now I know what to look at, significant value. Now I have a beta. With the help of beta, I can write the equation. Very good. Now, we have 6 variables, in which 3 variables only influencing, 3 variables are not influencing. Now, when the variables are not influencing, it is not good to include those variables into the equation, because it is not influencing. What is the fun in taking those variables into the equation? Right. So now I want to write an equation only with the 3 variable. Then please understand. Now this is the R square 0.999. That is the R square for all the variables. So we said already, even that variable is not influencing, R square might have increased. Even small, it might have increased. So now, if I include only 3 variables, my R square is not same. So what I have to do is, I have to rerun a regression with only 3 variables. Then I will get a different beta. The beta is not same, will not be same. I will get a different beta. Then I have to write a new equation. So it is not good to include variables which are not influencing. Okay, so I should avoid. Then I have to rerun, and I will be getting a different beta. I will be getting a different R square. I will be getting a new coefficient. Okay, so I have to run again. Okay, now I am not going to run. Okay, I am not going to run. I am going to use another method. Okay, I can find out here. Now I am going to one more thing. What is one more thing? Okay, I am going to see the standardized beta now. I am going to see the standardized beta now. Now, look at my standardized beta and beta. If the standardized beta is more, which means the influence of that variable is more. That is the important purpose of standardized coefficient. If the standardized beta is more, which means influence of that variable is more. But we cannot use unstandardized beta, because in unstandardized beta we have this much error. See here GDP error is very less. That is why standardized beta is more. Now here RIR beta is more, but standard error is also more. That is why my t value is very, very less. That is why it is not influencing. So the unstandardized beta estimates is an estimate with the error. Unstandardized beta estimate is an estimate with the error, with the standard error. But in a standardized estimate, I do not have error at all. Standardized estimate is an estimate without any error. So I can take as it is. If that beta is more, which means that influence of that variable is more. Simple. Okay, so that is the purpose of standardized coefficient. Now, based on, see, my first question is, which variable influence? That is looking at significant value. Now, what is the extent of influence? Beta, each variable x. Now, my third question is, The influence of which variable is more? Which variable next? That you can derive from standardized beta. That you can derive from standardized beta. So now here my standardized beta for GDP is 0.831. That influence is more. My per capita income is 0.482. That is the second variable. Now my saving is minus means this increase, that it decrease. But the extent is only the value 0.235. That is the order. Now, so that is what by using standardized beta, we can find out which variable is more important, which variable influence more. My GDP 0.832, the influence of that variable is more. Per capita income second, saving is third. Okay. Now I am going to use another method that is called the stepwise regression. Okay, I have one or two PPT only, no worry. I have a stepwise regression. How I will do? Same linear regression, same dependent, same independent. Here in the method, I use forward. Earlier, it will be enter. All will enter at one stroke. That is the enter. In a forward, that will happen like that. Forward, first variable influencing variable will enter first. Second influencing variable will enter second. Third influencing variable will enter third. Forward, one. First step, second step, third step. Forward, stepwise regression. Stepwise step. Stepwise regression. Stepwise step. Okay. So now let me run. Same code. Analyze. Regression. Linear. Yeah. Okay, I'm going to say okay. So now I have see here, I have a model summary table with many R square. I have a ANOVA with 3 models. I have a stepwise like this, right? Very good. Let me take the coefficient. Okay. Now, this is my coefficient table. Now look at this table. 1, model 1. In the model 1, what is the model 1? Where constant A is there, GDP is there, which means G is the most important variable. If you take only one variable, then it will take only one, GDP alone. Okay, so now see some people, many variables are there. I do not want many variables. I want only one variable, which is the most influencing variable. I want to write an equation only with that. Then I have A, 3081, then beta is 30. That's all. I have equation. Now, if you want to include only one, my equation is minus 3085 plus 11.38 into GDP. That's all. 11 or 13? 13. Okay. Okay. Now, suppose if I want to have one more, then what will happen? You cannot remove GDP, right? Because that is most influential variable. That will be there. But you can add one more. Alright. So the next is per capita C. Capita, per capita is coming. Now if I take two variables, what is my equation? Minus 4981 plus 7 into GDP plus 11 into per capita income. Now that you can see 7 into GDP plus 11 into per capita income, GDPC. Suppose I want to have one more equation with a 3, I can write 1651 plus 9 into GDP plus 11 into per capita minus 284 into savings. Now, like that, I can write 3 equations. Now, in a stepwise, it is taking only 3 steps. It is not going to the 4th step. It will not go. I have not stopped. I have not stopped to stop with the 3. It has stopped because only 3 variables are influencing. It will take only up to variables which are influencing. It will not take not influencing variable. So first we said only 3 variables are influencing. That you can decide now here itself. You need not see which is influencing, which is not influencing. Next is by using standardized, we identified GDP is 1, per capita income 2, and the savings 3. But that is also otherwise. In a stepwise, it has taken GDP first, per capita income second, savings. That is why we are running our regression. Stepwise regression is little better. Point number 1, you can write many equations. We can find what are the variables influencing straight away. Then we can find out which variable influence more, which variable influence less. Automatically, you can write. Okay. Even otherwise also, it's a simple multiple regression. Also, you can tell all the points. These are the variables influencing. These are all the most. These are all the beta. These are all the most influencing. First influencing. Okay. All you can. All you can. All you can tell. Okay. So this is the stepwise regression. This is the stepwise regression. So each step, if you it is improving, right? If you take 3 variables, square, adjusted or square, that variable is influencing. That variable is influencing. That is why adjusted or square also increasing. Okay. Now this is the ANOVA. Now the slope beta. Alright, I set a equation, right? Beta is equal to covariance, right? Y minus y bar into x minus x bar. Okay, divided by x minus x bar square. That is the beta slope, right? The intercept like this. Okay, t we know. Okay, so with this we are completing. Okay, thank you very much. Now, thank you very much. Now, if you have any question, you can ask me now.
Hello, Kasilingam sir. Hello.
Yes, sir. Good morning, sir.
Sir.
Yeah.
So first of all, it is a very enlightening session. Many of my doubts related to multiple regression got clarified, sir, today. Thank you so much, sir. And sir, my doubt is related to that income and saving example, sir. Please, could you clarify, sir? Sir, how can intercept be? I mean to say, how can constant be zero when there is no income?
Yes, sir.
How can
No,
saving?
okay. You are asking a very logical question. Okay, so with that is right. You are right. Exactly, you are right. But what I can give some example, right? So now let us assume that I am regularly saving for my daughter. I am very right. I'm having a chip scheme, which is my savings. So now in the Corona time, even they are not giving any things. I will save. What I will do is, okay, I will. So old might be there. I might have taken my wife's money, something like that. Irrespective of that, saving will take place. So that is why saving is, you heard about Robinson. Robinson, that lady, she says saving is not function of income. Saving is the function of last year income. Something like that. They have given a different version, right? Okay. So what is saving is a function of income. That is the theory given by the Keynes, right? Your question is a very good question, sir. Logical question, sir. Logical question.
Thank you so much, sir. I got it. Thank you so much. Thank you so much.
Okay, thank
Sir,
you.
I have one doubt.
Next.
Sir, again,
Good afternoon, sir.
thank you for
Next.
the session.
So here, sorry, yes. Yes.
Okay, so my doubt
Yeah.
is regarding Durbin-Watson. How do we judge Durbin-Watson and what is the role of Durbin-Watson?
No, so Durbin-Watson, I am not explaining here, sir. Basically, Durbin-Watson is autocorrelation. The question of autocorrelation will come only when you have a time series data. Auto. Okay, so correlation with the same variable. Okay, so collinearity is correlation between independent variable. Autocorrelation is its own variable. Now, your knowledge is depends upon your earlier knowledge. That is autocorrelation, right? But autocorrelation, whenever Durbin-Watson is 2, which means no autocorrelation. When it is less than 2, there is a positive autocorrelation. When it is more than 2, it is a negative autocorrelation. But it should be around 2, which means no autocorrelation. Which means error should not be autocorrelated. Errors. The variable can be autocorrelated.
Thank you, sir.
This year error, it depends upon last year error. Means you are not sufficiently predictive. The error is related, right? Which means error itself, we have to bring it to the equation. Okay, that is the meaning. So the error should not be related to each other. That is the meaning. That is the autocorrelation of Durbin-Watson is talking about. But in cross-sectional data, we will not use it. But given an example to give spurious regression, so where we will be looking at the Durbin-Watson.
Good afternoon, sir.
Clarify?
No.
Yes, sir.
Good afternoon, sir. Sir, some
Yes,
of the
yes.
multiple
Yeah.
regression.
Yes, sir.
Some of the multiple regression constant
Question.
is not significant, sir. That is not necessary, sir.
Constant?
Constant is not significant, sir.
Yes, sir. Yes.
That is not required, sir. Significant of constant value should not be significant. That is not required, sir.
Yeah. No. So I could not hear your question, sir, but I will give some answers, sir. Now, so with respect to first gentleman, okay, now he said whether without constant, if you want to predict that it will give, okay, which means it will not give constant value. Okay, that is number one. Number two, whenever you are influencing, whenever you are using some variable, that variable is influencing. When constant is significant, okay, so which means even without using this variable, your constant is significant, which means some other variables are really influencing. So the constant is taking care of the some other variables, constant and the residual. Constant is taking care of some other variables. So now, whenever your constant is significant, then you should be careful. Which means some people will ask a question. Sir, gentlemen, your constant is significant, which means apart from your independent variable, okay, so all other variables influence is significant, which means some other variables are there. Why you have not tried? People should ask that question. So whenever you are giving a final coefficient table, please see that constant is not significant. When constant is significant, which means your variable included are not sufficient. That is the indication you are getting. That is the indication you are getting. So you have to be careful in that. You have to be careful in that. Okay, so but constant is significant. Same concept is if it is less than 0.05, which means constant is also significant. But if you are, for example, if you want to publish in A-star journals, in those cases, they will look at each one. They will look at each one. If the constant is significant, they will write a very major question. They will major question. Okay, sir. Next. So my your doubt is clarified, sir.
Thank you, sir. Clarified, sir.
Very good.
Sir?
Yes.
Sir, shall I wind up the session? If any queries?
Yes, sir.
From the participants?
Yes.
Sir, shall I wind up the session, sir, for today?
Yes, sir. Thank you, gentlemen.
Sukumari,
now, tomorrow.
Sukumari, madam. Hello? Sukumari, madam.
Yes, sir. Thank you, Mr. Sukumar. Thank you,
Sir,
my
thank
dear
you very much,
participants,
sir.
for your very patient question, patient listening. Okay. So, in fact, you have very carefully listened. People have given very good answers. The questions are all excellent questions, right? So, see, these are all not very ordinary questions. All questions rise are very super questions, which means they are watching very carefully, very carefully. Very nice. Okay, thank you very much. Thank you.
Excuse me, sir. Some of them asked the question in YouTube channel, sir. Shall I read it?
Yes.
YouTube also, it is a live streaming is going on, sir.
Oh, I see.
They are asking some question. It is a live stream is going on.
Yes.
Sukumari, madam.
Yes, sir. Is T test and T values different? Is the question, sir? Is the T test and T values different?
No, T test, in T test also you will get a T value. Here also you will get a T value. In T test, T value is the difference in mean divided by standard error. Here the T value.
Okay, sir.
Right. So how it is calculated is different. But what is T? Same thing, like a T value table. Same T table. But how T is derived here is different from how T derived there. That is what I have shown. T, we will be using T in many places. Everywhere, estimate divided by standard error is the T. In a T test, estimate is difference in mean, because we are looking at whether mean is different, whether male using more, female using more. The difference in mean. The difference in mean divided by standard error. Here, beta is important. Here, beta is the influence. Beta divided by standard error. Okay. So that is the difference. Okay. Next question, madam.
Thank you, sir. Next question.
Next question.
What is test stat value?
What is?
Test stat value.
No, I don't understand.
The question is
Test stat value.
Yes, sir.
What is test? Where I have shown? I might have written anywhere a typing mistake is there. I do not know what he is talking about.
Okay, I think a test statistical value they are asked in short form. I think so, sir. Okay, sir. No problem, sir.
No, the question is not clear.
Okay, sir. Okay. Thank you for your
question is not clear.
Okay, sir. Thank you for the answer, sir.
If that gentleman can ask me in a phone, my phone, okay, so I will clarify what it is, right? So
Okay, sir, sure.
they can put in the mail also. I will clarify. No problem. Okay. So thank you, Mr. Sivakumar. Thank you, Sumari. Thank you, participants, everybody. So tomorrow we will meet by 10:30. Okay. So tomorrow I have to complete two things: factor and cluster. Okay. Thank you. Thank you very much. Thank you. Thank you. Thank you. Test statistics. Test statistics is the T statistics, which is nothing but beta divided by standard error. T is a test value. Feedback form not today. After 3 days only. After 3 days only. என்ன சிவகுமார் அப்படிதானே? Hello சிவகுமார்.
Yes, sir. Yes, sir.
Thank you, sir.
Thank you very much, sir. Thank you very much, sir.
Okay.
We'll meet on tomorrow, sir, at 10:30. By tomorrow, sir.
Okay, thank you. Thank you.
Sukumari, madam,
Yes, sir.
can you wind up the session, madam?
Yeah, sure, sir. Okay, sir.
Log it out, madam. Tomorrow we'll.
Wind up.
Okay, sir. Thank you, sir.
All the participants, you can leave from this Google Meet. Thank you for your patience. Tomorrow 10:30, we will join in this Google Meet link. Same link is available for tomorrow.
Thank you, madam.
Thank you, sir.